Today we're going to talk about rational and irrational numbers. Rational numbers are numbers that can be written as fractions, terminating decimals, or repeating decimals. Now remember we talked about this word terminating, and we said that it means stops or stopping. So decimals that stop. Example, 0.5, 1.248. Those numbers end. Now we know we can put zeros after them, but that's not what we're talking about right now. We're just talking about the numbers don't go on forever. Or rational numbers are repeating decimals. So decimals like 0.33 ... Or we could write it as 0.33 with a repeat bar. Those types of numbers are rational numbers. Irrational numbers are numbers that cannot be written as fractions. Cannot be written as fractions. They can be written as non-terminating or repeating decimals. So decimals that go on forever. And our biggest example of this is pi. Now don't get confused because pi is usually estimated at 3.14, but we remember that's just an estimate. The actual value of pi goes on forever. So it is an irrational number. Some of the other ones we talked about were square root of 2, square root of 11, negative square root of 13. So square roots of non-perfect squares. Also, numbers that you will see written like 1.3842 ... So the dots tell us that they keep going, but there's no pattern to be found. Those are irrational numbers. On your guided notes, there is a section that says classify. So we're going to classify some of these rational and irrational numbers. I want you to take the numbers that I write down and I want you to classify them on your guided notes. Rational numbers in their fraction form can be written as decimals. For instance, 1/2 can be written as 0.5. Well, the way we get that is you take the numerator and it goes inside. You take the denominator and it goes on the outside. And we have a division problem. And we say 2 can go into 1. Well, 2 can't go into 1, so I have to add a decimal and a 0. And this decimal place just pops up top there. And then we can say 2 can go into 10 5 times. And 5 times 2 is 10, and then we subtract. and I end up with 0, which shows that I'm finished. So 0.5 becomes our decimal expansion of 1/2. Let's practice changing a few more fractions to decimals. 3/8, I put the numerator inside and the denominator outside. And I say, how many times can 8 go into 3? Well, it can't, so I put a decimal and a 0. I pull that decimal up. And then I say, how many times can 8 go into 30? Well, 8 can go into 30 3 times. And 3 times 8 is 24. So now we're going to subtract. 10 minus 4 is 6. Okay, now, this time I'm saying, can 8 go into 6? Well, it can't, so a neat little trick I can do is I can add a 0 up here and drop it down. And now I have, can 8 go into 60? So 8 can go into 60 7 times. I didn't make my line long enough, so I'm going to fix that. So 7 times 8 is 56. Then I'm going to subtract. 10 minus 6 is 4. So same thing here. I want to know how many times 8 can go into 4. Well, it can't, so I'm going to add another 0 and drop it down. And now I have how many times can 8 go into 40, and that is 5 times. So 5 times 8 is 40. Then I'm going to subtract and I get 0, and that's what I want to end up with down here so that I know I can stop. So the answer is 0.375. So the decimal equivalent of 3/8 is 0.375. Okay, now we're going to change 1/3 to a decimal. So you remember from the other slide, I'm going to put the numerator inside the house, and I'm going to put the denominator outside. That's back to my elementary teaching. Now we say 3 can go into 10. Forgot my decimal up top. 3 will go into 10 3 times. 3 times 3 is 9. I'm going to subtract. 10 minus 9 is 1. Now, 3 can't go into 1, so I can add a 0 and drop it down. Notice what's happening here. Now I'm saying, can 3 go into 10? Okay, well 3 can go into 10 3 times. 3 times 3 is 9, and I need to subtract. 10 minus 9 is 1. 3 can't go into 1, so I add a 0, and I bring it down. And I say, can 3 go into 10? And it can 3 times. Do you notice a pattern here? This is a repeating decimal. So I can write it like 0.3 with a repeat bar, or 0.33 with a repeat bar, or I can write 0.333 repeating,